What's up, everyone? Lakonde Mwila here, back with another video, and we're talking K8s. Some of you might be aware that I've covered GitOps deployments to varying degrees in previous videos. But something I haven't given a lot of attention to is how to manage the release of a new application version that you just deployed to your cluster. And what do I mean by that? Well, deploying a new version of your application is the bread and butter of the development lifecycle. But you still have to think and strategize around how you're going to get this newly deployed version into the hands of your end users or whatever clients will be consuming it. And I'm not going to spend time going over the conceptual parts of GitOps deployments because, as I mentioned, I have videos that cover that in detail, so please check them out. I'll put some links in the description below. Let's talk about releases. And we probably all wish it was as easy as just putting it out there and moving on. But how do we know that our most recent changes work as they should? Can we use some mechanism to release it to a subset of clients to get an idea of the success and failure of this new implementation? Can we roll back in case things aren't working as they should? And can this whole process be automated? That's what I want to focus on. Let me start by saying that there are different approaches to tackling the challenges of releasing new versions of software. I'm going to focus on the Canary release strategy. Canary releases allow you to progressively roll out a new version of software to a subset of clients as a way of testing if the new version is working as expected. And the reason for this approach is to control the impact of the latest change on the client or end user base in a production environment. The progressive rollouts are based on a successful test criteria, and a rollback can occur in the case that that criteria aren't met. But how do we choose which clients get to experience the new version and which clients get the stable or current working version? And that's where routing and traffic management comes in. One way is to follow a weighted approach. The weights are expressed in percentages. For example, 80% of all incoming traffic gets redirected to the existing stable version, while 20% of the incoming traffic gets redirected to the newly deployed version. And these weights in the traffic can shift based on how the new version is performing. Now, as I mentioned earlier, this performance can be based on tests and their respective results, such as metrics and pre-configured thresholds for load and acceptance tests on the new version. Now, for this to work optimally, we need everything to be configurable and automated. Let's talk about how this is going to work in my implementation. I have a Git repository housing the source code for an orders microservice, and every time I commit a change to the repo, it will trigger a pipeline in GitHub Actions. Provided that the application successfully builds and passes the relevant tests, the new container image gets tagged and pushed to Docker Hub. Still in the CI stage, I clone the Git repo housing the Helm charts for the orders microservice and update the image tag with the new digest. And this will be under the deployments resource. This repo is being watched by Argo CD, which will compare and reconcile the detected differences between the live state in the managed cluster and the desired state in the repo branch. Once Argo CD deploys the new version to the cluster, Flagger will detect this change and spin up a Canary release in parallel to the primary or existing stable release. Flagger will then follow a weighted approach to progressively release the new version whilst actively checking the metrics for load and acceptance tests that will be run. Based on the results, Flagger will either continue to release the new version by incrementing the weights for the traffic or roll back. The traffic routing is handled by Istio. All incoming traffic will go through the Istio Ingress gateway, but the actual routing is defined by the virtual services. Virtual services are Istio resources used to define the routing rules to the services in the mesh. They have defined destinations for the incoming traffic of a defined host. In this case, the virtual service will have a destination route for the primary version and the Canary version. Flagger will auto-generate the virtual service and will manage the modification of the weights applied to the traffic routing between primary and Canary. Virtual services are concerned with traffic routing, but after traffic routing has occurred, you can apply additional configuration using Istio destination rules. When working with Flagger and Istio, the destination rules are automatically generated. Next up, I'm going to go over some of the code and the resources I've spoken about before capping things off with a demo. All right, I'm going to start by going over a change that I've made to the application source code for the orders microservice. And what I'm looking at right now is the controller, and this file contains the business logic for the GET request. You'll notice that I'm working with dummy data as opposed to fetching from an actual database. If I open up the browser, you'll notice that currently, there is no property for the type of delivery in the existing version. We've got the ID, the product ID, order for, delivery address, and delivery date. Now, bear in mind that that is the live version deployed to my EKS cluster and is being accessed via the Istio ingress gateway, and then the gateway then routes that traffic based on the virtual services, and the virtual services in turn proxy that traffic through to the cluster IP service, and the cluster IP service is what is fronting the orders pods. Now, I need to change that version because I want to be able to have a delivery type. Let's say with an actual e-commerce application, it's usually a good feature to have a way of expediting the delivery process for people. So let's have a delivery type added in there. And so what I'm adding here, you'll see some are standard and some are fast delivery. And it's kind of self-explanatory if you've worked with any kind of real e-commerce website. Now, with this change, I've also updated the package.json file. You'll notice over here, the new version is going to be 0.2.8. This reference is specifically for my Docker image tags so that I'm able to identify them when they're inside of my Docker Hub repository. However, inside of my cluster, I actually want all my deployment resources to reference image tags using the hash digest because that is immutable as opposed to zero, as opposed to using the semantic version. So if I come over here to orders, and right now I am in Argo CD, I'm looking at the orders application. If I come to deployment over here, just so you can see exactly what I'm talking about, I'm going to scroll down and you'll see, there we go. So under the image, and there is the hash digest. So that's what I want to stick to using. And you'll see how I'm able to fetch that when I go through the main.yaml file. Right, so something else that's really important under the orders application is to consider the fact that when Flagger is actually running a couple of tests, that is load tests and acceptance tests, is going to be continuously checking the metrics based on the results of those tests that are going to be running. And so I'm going to be using Prometheus, which is also deployed to my cluster. And so Flagger integrates really well with that as well. And so I just installed the prom client to my Node.js application. And so this is a way of exposing the metrics for this application so that Prometheus can then scrape the metrics for any incoming requests, and those incoming requests will be based on the tests that will be running when I do deploy a new version. So you can see over here, this is where I create a registry to register the metrics. And then lower at the bottom over here, you'll see that this is where I'm creating another route, and you'll see the endpoint metrics. And so this is where the metrics will essentially be exposed. All right, last thing to cover under the orders section is the main.yaml file. And this is the main configuration file that drives the behavior of the CI stage. So when this change is actually committed, when the changes are committed and pushed to the remote Git repository, GitHub will detect those changes and GitHub Actions will get to work. And so a lot of this source code has been used in previous videos of mine, because this is a main example application I like to use, and I make slight tweaks to make it fitting for the particular video. So if you do feel like I'm not diving deep enough, I do encourage you to check out some of my previous videos where I get into a lot of details about these different aspects. But right now I do want to focus on the main topic at hand, which is Canary releases. This is just more for context. And so as per norm, as you can see, so this is going to trigger on any pushes to the main branch. And I've got some environment variables over here that are defined based on secrets in my GitHub Actions. I've got the Docker ID and the Docker password, and those are my credentials for my Docker Hub registry. And also, I've got an access token. This access token is so that I can be able to clone another Git repository, and that other Git repository will be the one that contains the Helm charts for the orders microservice. The fourth one over here is a token for the tree. I'm actually not using the tree in this particular video, but I've got other videos dedicated to that. So please check those out. So I'm not going to delve into that in this one. All right, now I'm going to focus on the steps. I do try to make sure that the comments and the names of the steps are self-explanatory and self-documenting and helpful to know what's going on. As you can see, in the CI stage, I'm installing Helm. As mentioned, I'm not really using the tree in this one, so this shouldn't be here. So we'll consider this dead code. So I'm not going to get into that. And then, of course, installing the Node.js dependencies for the application. As you can see, the version that I'm running, and then I execute the npm install command. I log into the Docker registry using the credentials from the environment variables, which, as I mentioned, the values are stored in GitHub in the secrets section. Then the last step is for the installation of dependencies, that is to install YQ, because YQ is what I'm going to use to actually modify the YAML configuration files inside of the Git repository that has the Helm charts. Right, so the next thing to do is the real meat of any CI stage, and that is to actually carry out the building and the testing of the application. So I start off by running npm run test to run a test against the orders microservice to make sure that everything is as it should be based on the most recent changes. And provided that those tests pass, I then fetch the version number, which is taken from the package.json files you can see over here. So that's the semantic version 0.2.8, and that's the tag that I'm going to use for the image that gets built, as you can see over here, Luconde F Mwila / e-commerce orders. And so this is what is going to be pushed to Docker Hub. And you can see that is the command I then run over here. So now I've got a new version in Docker Hub, which is going to be version 0.2.8. Now, as a last step, I need Argo CD to become aware of the fact that there is a new version, but Argo CD is only going to be aware of that based on its single source of truth. And Argo's source of truth for this particular application is in a Git repository where the orders Helm chart lives. So what I need to do now is I need to clone that Git repository that has the Helm charts, and that's what's happening over here. And you can see I'm cloning it into a temporary folder, and then I CD into application charts and then specifically to orders. Now, if you want to see what this actually looks like, I'm going to come to the browser and I'm going to open up this Git repository. Bear in mind, this is public, as you can see over there, so please feel free to make use of it. I'll try to dump as many links as possible in the description below so that you have enough references to know what's going on. And so this is the repo that I cloned. And so I basically CD'd into the orders directory where I have my Helm charts, and I also have my values-dev file. And so the values-dev YAML file is what is actually driving the configuration for the specific development environment, which is the only environment I'm working with in this case. And now what I want to do is I want to make a change to the image tag under the new deployment property. Now, let me get rid of any confusion here. You might be wondering, why on earth is it called new deployment and not just deployment? So this is specific to this orders microservice because I have a slight difference inside of this particular one. I'm using an umbrella chart, and all of the templates are stored inside of the e-commerce platform. This is where the umbrella chart is, and then this is where the templates are. And so you'll see I've got a normal deployment, and this is the one that the other microservices are referencing. And we've got new deployment. So new deployment actually works the same way as the other deployment one. The only difference is I am now switching over to using a hash digest, and I just need to make that change for the others as well. So as soon as I've done that, we'll get rid of this concept of new deployment, and we'll just have the single one. So there's some additional context. I hope I didn't throw you off track too much, but I certainly don't like it when there's some cloak and dagger and people are left wondering what on earth is going on. So back to values-dev. Argo CD has an application which is watching this. So remember, in the context of Argo, applications are custom resources which are essentially a link between a Helm or a Git repo branch and a Helm repo or a Git repo branch and a specific destination on your cluster, such as a namespace on your downstream cluster. And so Argo CD is watching this as its source of truth, and it will then deploy any changes that it detects based on the live state in the downstream cluster. Now, obviously, that is configurable. If you don't want it to auto reconcile, then you can manage that process. In my case, it will automatically deploy the changes. So this is the current version. So let me come back over here. And so I update
my values-dev file with the new digest. And if you're wondering where you're getting that digest from, so you'll see over here, I'm running the Docker manifest inspect verbose on the image that I just built on that specific tag, and then I'm using JQ to fetch the specific digest. All right, and so that's what I'm using to update the values-dev file. And once that is done, I then cd back to the root so I can commit those changes and push them back to the origin. And once that change takes place, Argo CD will then be able to see, oops, there's a difference over here between the downstream cluster and my source of truth. I'm going to go to work and make sure that that change happens. All right, so next up, another important piece that I'd like you to see, this is probably the crux of everything, and that is the Flagger custom resource definition that drives how a canary, how the canary release is actually going to work. As you can see, the name of this property is orders, and it is deployed to the e-commerce namespace. And very important over here, as you'd expect, under the spec, we need to reference the specific deployment that we're targeting. And as the property states over here, target reference, and that is the orders deployment, so that Flagger knows the specific workload that it should actually be referencing or applying the canary release to based on a detected version change. All right, so when Argo CD detects the change in the repo and rolls out the new version, Flagger will then take over from there when it sees the new version and get to work and actually spin up a canary version, and it will work with Istio to split that traffic between the two. Versions, that is, the primary version and the canary version. A lot of the properties here are self-explanatory, but I do want to highlight a couple of them. So the service property is important. So this is obviously referencing the service for your workload. And so you'll see the service port number is 3003. That's referring to the cluster IP service for my orders microservice. And the target port is for the actual container. So again, just so you can see that clearly, I'm going to click on orders service over here. And you can see that this is a cluster IP service, and the port that it's listening for traffic on is 3003, and the target port for the actual application is 3003. All right, so another important step is specifying the gateway. And so I have a gateway named public e-commerce gateway, and we'll get into that shortly. That's the file over there. And this is running in the Istio system namespace, which is why I've specified a full host name over here, as you can see, so it knows exactly where to find it, as opposed to assuming that it's in the same namespace. And then under hosts, I've got a wildcard, and this matches the same wildcard for the hosts in the gateway configuration as well. And I'm going to scroll down here to the analysis. And under analysis, this is where I get to configure how the canary release process is going to work. For example, how often should it actually make a change in terms of the percentage weight? So you'll see over here that I've specified I want an interval of 10 seconds. So there should be a change every 10 seconds. And then the threshold over here refers to the failure threshold. So remember, because Flagger is going to be continuously checking the metrics that are being scraped by Prometheus, and Prometheus is scraping those metrics from the application based on that endpoint that is exposed and the tests that will be running. And Flagger, and you get to define what the maximum number of failures is. And so I've set mine to 5. And in the case that maxes out, then we're going to roll back because clearly there's something wrong with our new version and we don't want to proceed with the release. In the case that it remains under the threshold, then we want to continue. But we've defined the intervals, which is 10 seconds. We've defined the threshold, but how do we know what those steps should actually look like in terms of the increments in the weight? And so that gets defined over here, step weight, and I've set mine to 10. And you also get to define the maximum weight. And so I've set mine to 50. So this is essentially a split between the primary release and the canary release. So you could have yours hit up to 80% if that's what you like, but mine is basically if it gets to 50%, then I'll be satisfied with that. It will start off with at the moment, the primary release has 100%, and that is gradually going to reduce based on the changes successful changes taking place with the Canary release based on those tests. I'm going to scroll down further and come to the webhooks. And I have deployed an additional resource called the Flagger Load Tester. I've also put a link to that in the description. And this has been deployed to the e-commerce namespace. And the Flagger Load Tester is what I'm using for my acceptance tests as well as for my load tests. And so you can see over here that under the metadata, the command that is going to be run is a curl request. So this is something that you can even do in your terminal to make sure that it's working as expected. And so this curl command will reach out to this particular endpoint to make sure that I get that there is a property that exists called delivery type, because the new version coming out is going to be delivery type. And then we have another one over here, which is essentially just going to be querying the orders endpoint to make sure that it's working as expected, because it's the same GET request where that new property is going to be added. In the case that you had a different endpoint, then obviously you would update these accordingly with the specific properties or the types of tests that you wanted to run. But I hope this paints the picture. All right, next up, we have the gateway resource. And I've covered this in greater detail in previous Istio videos, but this is essentially how you get to configure the Istio ingress gateway, and mine is named Public E-commerce Gateway. This is the same resource that will be attached to the virtual services that will be auto-generated by Flagger. In the case that you weren't working with Flagger, you would have to create the virtual services. And remember, the virtual services manage routing. Okay, so this is where you configure what kind of traffic can come in. The ingress gateway configures that, it manages the configuration in terms of the protocol and the port number that we want to listen for traffic on, and the hosts as well. So as you can see over here, I'm expecting HTTP traffic on port 80, and I've listed a wildcard for the hosts. The virtual services will be automatically generated by Flagger. And that actually reminds me of a very important step that I left out over here. So the configuration for your virtual services is essentially influenced by the configurations in this particular file as well. And there is a property, there we go, HTTP match conditions. So obviously, as you can see over here, it is optional, but because I want to specify the match, the URI that has to be matched, that is the condition for the particular orders microservice, I've set this prefix over here as version 1 / orders. And so the incoming request has to have this specified in order for the routing to work correctly. So the virtual service that gets created will then, by Flagger, will then have this particular property. If you want to see what that looks like, I'm going to quickly come to K9S, and I've gone to virtual services. As you can see under gateways, public e-commerce gateway. This is the one gateway that I've created. I'm going to hit the describe command, and I'm going to scroll down, and you'll see here under HTTP match URI prefix, we've got v1 orders. So that's to make sure that routing actually works as it should once traffic has come through the gateway. And another resource that Flagger also creates for you is the destination rules. So I'm just going to punch that in there, destination rule. So Flagger will create the destination rules. And so this is the configuration for what happens after routing. So remember, virtual services manage the routing, and then we're going to have a primary and a canary, because we're going to have two different services, because traffic is going to be proxied through to two different versions that are going to be running in parallel. All right, so the last thing to do now is to actually check this out in action.
thanks a lot for watching. I hope you found that useful. If so, hit the like button, subscribe to the channel, and stay tuned for more.